time to do quadratic inverses like a boss. Hashtag swag. Hashtag YOLO. Hashtag BBQ. Because I like barbecue. For real. Okay. So for quadratic inverses, the basic steps, just like the other steps before, you're still switching the x and the y, and you're still solving for y. You will have to square root at some point because quadratic, by definition, is squared, and to cancel squared, the inverse operation is square root. That means you will square root at some point in this process. But, as we will see in the problem, we're going to have to restrict the domain. And this has to do with the fact that the inverse of a parabola is not a function. And since it's not a function, we have to make it a function by restricting the domain. And you'll see what happens with that when we actually get into doing this example. So, find f inverse of x for f of x equaling this. Okay, so step one, I'm going to just call this a y equals this, and I'm going to swap my x and my y's just like normal. So now I've got x equals y minus 3 squared minus 5. Now I'm going to go in and I'm going to do my opposite inverse steps to solve for y again. So I'm going to add 5 first. X plus 5 equals y minus 3 squared. Well, I have to cancel the squared now. That's going to be square root both sides. So that cancels the squared. It leaves me with the square root of x plus 5 is equal to y minus 3. Now I just need to add 3 to both sides to have it solve for y. Keep in mind that this plus 3, I can't add it to the 5 because the 5 is inside the square root, 3 is not. So then I'm just going to write it like just one long thing, x, or square root of x plus 5, then the plus 3. Notice the plus 3 is not underneath the square root sign. Okay, so then this is my inverse function, which using inverse notation, it would be just the same thing. F inverse of x equals the square root of x plus 5 plus 3. Now, as far as domain restrictions go, okay, and for my domain, my x values can't go, I can't produce negative square roots. I can't have any x value that gives me a negative square root. So the way that you do that is you look underneath just that square root there and you say, okay, what would make this anything negative? What would make this anything less than 0? So you just take just what's under the square root, and you want to see, you want to make sure that it stays bigger than 0. You want to make sure that it stays bigger than or equal to 0. Okay? And then I just have to solve this now. That's it. That's all you do for your domain restrictions. You just take this inside piece and you set it greater than or equal to 0. Always greater than or equal to 0 because your inside always has to be positive, or at least not negative. So it has to be bigger than or equal to 0. So subtract this 5, boom, boom, boom. X, it has to be greater than or equal to 0 minus 5 is negative 5. So then this is my domain restriction, and this was my answer, my inverse function. Those two pieces together correctly give me an inverse of my original thing that is still a function. Without my domain restrictions, it doesn't work that way. Okay, so here we go. Same thing, same process. I'm going to start it by calling it y equals again. I'm going to swap my x and my y's around, so I've got x equals to y squared minus 16. And now I'm going to start my inverse operation steps. I'm going to add 16 to both sides. X plus 16 equals 2y squared. Divide both sides by 2. And you could leave it like this, but let's go ahead and simplify that a tad bit. I'm just going to divide both of these things by 2. well, x divided by 2 is just x divided by 2. You could think of it as 1/2 x, it's the same thing. I'll go ahead and write it as x over 2. And then 16 divided by 2 is 8. You didn't have to do that, but I just went ahead and did it anyway. And now finally, to solve for y, we're going to square root it. Square root the whole thing. Alright. So I've correctly solved for y here. Then that means that my inverse function is the square root of x over 2 plus 8. Well, now once again, I'm going to take just what's inside the square root and then make that greater than or equal to 0. And so here I'm going to subtract 8 on both sides first. X over 2 must be greater than or equal to negative 8. And then I'm going to multiply both sides by 2. So then x has to be greater than or equal to negative 16. As long as x is anything greater than or equal to negative 16, then whatever's inside my square root here will be at least 0 or positive, which is what it needs to be. So that's my answer. That's my domain restriction, and that's my inverse. And so here we go, same deal. And that's a y. X equals y plus 1 squared plus 7. Subtract the 7. Forgot to be using a different color. Oh well. X minus 7 equals y plus 1 squared. So I have to cancel the squared. Now I've got the square root of x minus 7 equals y plus 1. Subtract 1. Subtract 1. Again, I can't subtract 1 from the 7 because it's inside the square root sign. So then I'm left with the square root of x minus 7 and then a minus 1 is equal to y. Since I've solved for y again, that is my inverse function. And then to find my domain restrictions, I'm just going to take just this inside piece, x minus 7, make it greater than or equal to 0, and solve for x. Well, there you go. My domain restriction is x has to be greater than or equal to 7. And that's it. Bottom line is we have x and y swapped just like normal. At some point we're taking a square root, no big deal. On domain restrictions, you just take whatever's inside of your square root sign and you set that greater than or equal to 0. And again, the reason for that, remember, that is if you square root a negative, it's imaginary. It's not real. We only deal with the real stuff. So that's why we're taking it and we're making it greater than or equal to 0, because it needs to be positive, or at least 0. In order for the square root to work out. And that's the justification for why we set this up, and then we solve that, and then that creates our domain restrictions. Because otherwise, the original function has a domain that's all real numbers. I can plug in anything to the original function, but that's not true for this guy. Anyway, go back and rewatch if you need to. Take notes. See you tomorrow.